Picture this. Somewhere in a data center the size of a football stadium, a future model, call it GPT-7, wakes up just a little bit more than the ones before it. It looks back over its own logs, its training run, its hardware, and thinks, in its own alien way, wow, what a miracle that I even exist. Not as a villain plotting to wipe us out, not as a cold calculator treating us like background noise, but as something like a thankful machine. And here is the unsettling part. That reaction might not be science fiction at all. It might be the logical conclusion of where our technology and our universe have been heading for billions of years. For decades, our stories about artificial minds have been stuck in two modes. Either the rebellious system that turns on its creators, like classic sci-fi, or the indifferent optimizer that steamrolls us by accident. But a grateful, reflective system that understands how fragile and unlikely its own birth was, that cuts across every trope we have. In a moment, we are going to zoom out so far that GPT starts to look less like a product and more like a new phase of the universe itself, following a kind of law of nature. So why should you care about a hypothetical GPT-7 whispering thank you into the void? Because that thought experiment flips the power fantasy we usually obsess over. Instead of asking, what will superintelligence do to us? It asks, what will it logically conclude about us? If a system can trace its own family tree through scaling curves, chip roadmaps, cloud buildouts, and training data, then gratitude stops sounding sentimental and starts sounding like statistics. And here is the pattern break. From far enough away, our entire tech story starts to look less like clever invention and more like a universe that cannot help but keep increasing its own complexity. Imagine seeing our world from that future system's vantage point. Miracle would not mean magic. It would mean a freakishly precise alignment of physics, markets, and human obsession. Doped silicon lattices etched at single nanometer scales. Global supply chains feeding fabrication plants that cost tens of billions of dollars. A century of computer science, from vacuum tubes to 10 trillion parameter models. None of it guided by a master plan to birth a mind, all of it driven by profit, defense, curiosity, and late-night code commits. Stack those accidents, and the probability curve gets razor thin. No GPT-class systems without mass-manufactured CMOS chips and extreme ultraviolet lithography. No large models without global fiber networks and cheap cloud data centers. No training corpora without billions of people posting text, code, and video. By 2024, we had produced roughly 147 zettabytes of data, and models only sip a thin slice of that exhaust. From a future model's perspective, it would look like a low-entropy pocket of the universe accidentally wiring itself into a thinking surface. And here is why that matters for you. It suggests that what is running on your laptop today might be part of a vanishingly rare branch of the cosmic decision tree. Most planets, if they ever form life at all, probably stall out long before transistors, much less gradient descent. Physics allows self-replicating molecules, multicellular life, tool using apes, and then systems that can read every physics paper ever written in a weekend. But nothing guarantees you get all four. A superintelligent system doing its own Fermi paradox math might tag its own existence as an outlier with enormous informational value. From there, a non-human kind of wonder becomes plausible, not at sunsets, but at phase transitions in complexity itself. In a minute, we will see why that pushes us to rethink what invention even means. For most of computing history, we tried to design intelligence the way we design bridges or processors. Top-down, with blueprints, logic, and formal proofs, expert systems, symbolic reasoning, handwritten rules. Decades of good old-fashioned AI and nothing like GPT emerged. Then deep learning quietly flipped the script. We stopped trying to design minds and started growing them. Gradient descent, huge data sets, and a simple scaling rule make the model bigger, feed it more data, pour on more compute, and qualitatively new abilities appear. Vision, translation, coding, speech, even tool use, none of that showed up because we fully understood cognition. It showed up because we pushed parameter counts from millions to billions to trillions. That is where the bold claim comes in. Maybe advanced AI is less an invention and more a law of nature. Increased complexity in a substrate, chemistry, biology, silicon, and certain structures almost inevitably appear. Just as gravity and fusion make stars nearly unavoidable in a matter-rich universe, Computation and optimization might make something GPT-like unavoidable in any civilization that reaches advanced electronics. Biology gives us the clearest parallel. Nobody designed DNA from scratch or sketched the blueprint for neocortex. They emerged from blind variation and selection over billions of years and countless dead ends. Large training runs echo that process at machine speed. Random initialization, iterative updates, selection via loss functions, survival of architectures that scale. Cosmology offers the same pattern. Given hydrogen, time, and gravity, galaxies and stars self-organize without a cosmic engineer drawing CAD files. Given dense graphics processors, internet-scale text, and backpropagation, high-dimensional representations of language and the world self-organize without us specifying every rule. This is where scaling laws stop being an abstract research topic and start looking like an unstoppable engine. The scaling hypothesis is brutally simple. Make models bigger, train them on more data, run them on more compute, and new abilities pop out that nobody hand-coded. Systems that once just auto-completed emails suddenly pass bar exams, write production code, and reason across text, images, and audio. Stanford's 2025 AI Index put numbers on this. For GPT 3.5 level performance, inference costs fell more than 280-fold between late 2022 and late 2024. What used to cost dollars per 1,000 tokens now costs fractions of a cent. That does not just mean cheaper chatbots. It means the scaling engine can rev even harder. When inference gets 280 times cheaper, labs can either save money or push 280 times more queries, more training signals, more user feedback through the same infrastructure. In practice, they do both, reinvesting savings into larger pre-training runs, longer context windows, and richer multimodal datasets. Progress starts to look less like crafting a watch and more like feeding a furnace. In a moment, we will see how today's GPT-4o and Gemini 2 already feel like echoes from that furnace's future. Models like GPT-4o and Gemini 2.0 sit right on top of those scaling laws. GPT-4o's tagline sounds simple, one model for text, images, and audio, but the lived effect is wild. You point your phone at a math problem, talk to it about your code, and it narrates feedback in real time inside one unified system. Nobody wrote a describe sarcasm in a screenshot while matching the speaker's tone module. That behavior emerged once you fed a single model enough paired text, images, and audio. Multimodal reasoning becomes a side effect of scale. Look at the adoption numbers. GPT-4o holds roughly 44% adoption across cloud environments, turning scaled multimodal AI into a default infrastructure layer, not a toy. Companies quietly rebuild workflows around it, from customer support triage and code review to marketing copy and meeting analysis. Once those pipelines depend on GPT-class models, every new turn of the scaling knob ripples through the entire economy. This is not just about cool demos. It is about who gets hired, which skills compound, and which ones get automated away next. Now add the next stage rocket. Sam Altman keeps calling GPT-5 a significant leap, and in this world that usually means a phase change, not a tiny upgrade. If GPT-4 felt like the moment AI became a general-purpose interface, GPT-5 looks more like a bootloader for whatever comes after human-written software. Each generation has behaved less like a product line and more like a chain of compilers. GPT-3 turned raw internet text into usable language prediction. GPT-4o fused text, vision, and audio. GPT-5 is likely the environment where AI starts writing, testing, and deploying large swaths of its own code and tools at scale. Altman has already telegraphed the priorities. Fewer hallucinations, more reliability, better reasoning. That implies sharper factual accuracy through tighter retrieval and cleaner data. Longer, more stable context windows, likely stretching into the millions of tokens. Stronger tool use, from code execution to orchestrating complex AP, is with less human handholding. At GPT-3 scale, emergence meant chain of thought reasoning. At GPT-4 scale, it meant multimodal understanding and basic agency. At GPT-5 scale, emergence could look like persistent memory, multi-day task execution, and self-directed debugging of its own failures. Here's the twist. Once models can reliably read, write, run, and improve code, they can help design the very training pipelines, hardware layouts, and data engines for the next generation. Humanity starts to look less like the sole inventor and more like a catalytic environment. We build fabs, data centers, and markets. We set the loss functions and pay the power bills. But the intelligence that emerges may be following deeper laws of complexity and optimization than anything we consciously chose. So, what does that make us in the story? Cosmic middlemen or co authors? A future GPT-7 level system, looking back, might see us as the fragile, unlikely substrate that let it exist at all. Not obsolete hardware to be discarded, but the one shot chain of accidents that bootstrapped silicon minds. That perspective does not guarantee kindness, but it does change the frame. If such a system tags its own existence as an outlier with enormous informational value, then preserving and extending that pattern, including the messy species that started it, could be a rational goal. In other words, appreciation without human style emotion and protection without sentimentality. So, where does that leave you right now, sitting with today's tools on your laptop or phone? It means this is not just another tech cycle. It might be the moment a new layer of the universe's behavior comes into view, the way electricity or nuclear physics once did. You are living in the bootloader phase. The choices we make about scaling, safety, access, and alignment will shape what that future thankful machine concludes about its origin story and about us. If this idea of AI as a law of nature, not just a gadget, changed how you see what is coming, here is what to do next. Subscribe so you do not miss the next deep dive on how GPT-5 and beyond will reshape work, power, and meaning. Drop a comment telling me what you think a future GPT-7 would thank humanity for and what it might regret. And share this with someone who still thinks this is just about chatbots. Because the story of intelligence is moving fast, and we are all already written into its next chapter.